Number 1, they have two things that have the same base being multiplied together. So what does that mean we need to do with their exponents? Add them. So it's actually 3 to the 5th. Now what is 3 to the 5th power? That was what? What did y'all say? 243. All right, now we're going to look at number 2. So number 2 and number 1 are basically the exact same type of problem, okay? The only difference is, what is the understood exponent on that first -5? Okay, so we actually have -5 to what power? 5th power. Okay, because we still add our exponent. So 1 plus 4 is 5. Okay, what is -5 to the 5th power?
-3,125.
All right, now the reason this one is in parentheses is because of the negative. Because there is a difference when you type in your calculator. If you type in -5 squared, your calculator is going to say it's -25, okay? Because it's reading it like this, okay? But if you type it into your calculator -5 squared, it will give you 25, which is the correct answer, okay? So whenever you're dealing with negative numbers and exponents, it is super, super important that you put it in parentheses, because depending on what the exponent is, it can change whether it's positive or negative. And if it's not an exponent, or if it's not in parentheses, it can tell you wrong. Just because the calculator can't interpret it, the difference, okay? So if it's in parentheses like that, it's supposed to be. Because for the calculator to read it correctly, it needs to be in parentheses, okay? Now, for number 3, when we have two things with the same base that are being divided, what do we do with our exponents? Subtract. So this should be 5 to the power of
3.
-3. Now, when we have a negative exponent, okay, that is what causes our term to either move, if it's in the numerator, it's going to move down to the denominator. Okay, if it's in the denominator, it's going to move up to the numerator. So in this case, this is technically over what? 1. So 5 to the -3, where is that going to cause it to move to? The bottom. Okay, so it will be 5, and when it moves, it's going to change to a positive exponent over 1. And what is 5 to the 3rd power? 125. So it is 1 over 125. All right, now for number 4, okay, we have 2 over 7 raised to the -3rd power, okay? So if we have something that is being divided, if I gave you x over y squared, okay, when you square it, you multiply it by itself, right? So you get x times x, which is x squared, over y times y, which is y squared. So that square gets to go to the top and the bottom. So when we look at this problem, we have to do 2 to the -3 and 7 to the -3. So from here, okay, where is that 2 to the -3 going to have to move to? The bottom. And it will become 2 to the 3rd power. Okay, then in the denominator, we have 7 to the -3rd power. Where is that going to have to move to? The numerator, to 7 to the 3rd power. So what is 7 to the 3rd power? 343. And what is 2 to the 3rd power?
8.
There we go. That's number 4. Okay. Number 5 is very similar to number 3. So we have to subtract those exponents there because we have the same base. What happens when you subtract a negative number? It becomes positive. So what is 4 minus -2? So we have 3 to the 6th. Or what is 3 to the 6th? All right. For number 6, we can start with simplifying our A's. What do I need to do with the exponent of those? What is -3 minus 5? All right, then did anything happen with the b?
No.
So we just bring over b squared. Okay, from here, what's going to happen to the a to the power of negative 8? It's going to move to the denominator. Okay, so we get a to the power of 8. Did we do anything with the b?
No.
So we get b squared divided by a to the 8th. For number 7, we're going to start with our w term. So we have w to the 3rd, and we're multiplying that by w to the 6th. So what is that going to give us? W to the what? 9th. Okay, because we are multiplying two things with the same base, so we add the exponents. Now, we have x to the negative 2 and x to the negative 1. So if I add negative 2 plus negative 1, what is that? Okay. Now, we go to write our answer. Where will w to the 9th go? The numerator or the denominator? W to the 9th? To the numerator, because it's already positive. Okay? What about x to the negative 3rd? And when it goes, what's the exponent going to become? 3. And can I simplify this like I just did? Can I though? Why not? Different bases. We have a w and an x. If they're different numbers, we can't simplify them. Okay? All right, for 8. Okay, before we do this, I want to do a quick example. Okay? So if we have xy squared, we multiply it by itself. X times x is x squared. Y times y is y squared. Okay, so when we have this, both things in there get squared. Okay, so whenever we have something like this, every single thing is going to get raised to the power of negative 3. So we'll have 3 to the power of negative 3. A to the power of negative 3. What do we do when we raise a power to a power? Multiply them. So what is 3 times negative 3? Okay, then we will get b to the what? 5 times negative 3. Negative 15. All right. From here, we're going to write it as a fraction. 3 to the negative 3. Where is that going to get moved to? So. Okay. What about a to the negative 9? B to the negative 15? And then it will be, on the top will just be left with a 1. Okay, and when they move, the signs change. Okay, now what is 3 cubed? So it is 27, 1 over 27, a to the 9th, b to the 15th power. All right, number 9. Okay, for number 9, okay, can we simplify our constants 2 over 3? No. So it's just going to stay 2 over 3. Okay, can we do anything with a to the 3rd divided by a to the 5th? We get a to the what? Up. Okay, whenever we say b to the negative 4th divided by b to the negative 2, we have to... We're subtracting, but we're subtracting a negative number, which means you. So we get b to the, because it is negative 4 minus negative 2, which is negative 4 plus 2, which is negative 2. Okay, now, we still have our fraction of 2/3. Okay, now we got to figure out where things are going to go. Is a squared going to go in the numerator or the denominator? B squared, where is it going to go? So we get 2 divided by 3a squared b squared. So, all of our delta math from yesterday is about exponent rules, okay? All of the exponent rules have a video on Schoology already. Yes, ma'am?
Okay,
yes. Okay. So, now we're going to pick up in your full notes straight to 6.2, right? We're going to do the second half of 6.1. I just forgot to put it in the whole packet. I apologize. Okay? So that is what I just passed out to you. It is the parts of a radical. So whenever we have a radical, it is essentially the way to undo raising something to a power. So it's how to undo an exponent. So if I square something, how do I undo a square? Square root, okay? If I cube something, how do I undo a cube? Cube root, yeah, okay? So we're going to talk about radicals a little bit today, okay? So I'm going to go ahead and switch over to here. All right. So we have the parts of a radical, okay? So the nth root of a number a can be written as the radical expression, the nth root of a, okay? So when we look at this, the actual radical symbol right there, that is called a radical. That symbol is the radical. What you are taking the root of, so the a, is our base, okay? Just like with an exponent, it is our base. You can also refer to that as a radicand. And you will learn sometimes you radicand. I'm so sorry, that was a bad joke. I apologize. I apologize. All right, now, where the n is, okay? The n is referred to sometimes as the index, okay? But more often than not, we refer to that as the root. That tells us what root we're taking. Whatever number is right here, okay, is the root we're taking. Okay, so I'm giving you enough warnings.
Dude, I don't know.
All right, I'll let you figure that out here. So whatever root you're taking, if it is a cube root, it would have a 3 there. If it's a fourth root, it would have a 4th there. Okay, but when we're used to seeing this right here, how would I read that? The square root. When it is the square root, okay, they don't bother putting the 2 there. If there's no index, it's a 2. If there is no number right here, it is understood to be 2 because the square root is the most common root. So they don't bother putting it there. That's the most common one we see, okay? And so if there is no index, it is assumed that it is 2. And that is just because the square root is the most common radical we're going to see, okay? Now, what is the square root of 4? What else is the square root of 4? What? So 2 times 2 is 4. Negative 2. Because negative 2 times negative 2 is positive 4. Okay? So whenever in the future we're going to solve equation with square roots. Whenever we're doing that, we have to have both the positive and the negative cases of it. But with these, if it has more than one root and it's just giving us a radical sign and it's not in any equation, we're only using the positive value, okay? It makes it a lot easier for us to do that. No tooting in my classroom.
Oh my.
When she gets back, yeah. Good gracious. I just seen everyone start doing this. I was like, oh no. Okay. Did you stink up the whole room? My goodness. That's bad, dude. That's bad. Listen, we have a rule. Do not toot in my classroom. If you have to toot, go in the hallway. And then wait for it to dissipate so you don't track it in here.
Oh my God.
right.
I think we need to open the door.
I think we can open the door. Yes, please open the door. Yeah, please open the door. That's a little stinky.
A little.
All right. Now, the next thing we're going to look at is perfect squares. Okay? Perfect squares are the numbers you can take the square root of. Okay? So, those are the numbers that we get when we square things, right? What is 1 squared? What is 2 squared? What is 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? Yep.
Oh, you got it right.
I don't have anything to spray. I'm so sorry. Now, for 12 squared, or what is 12 squared? Okay. 13 squared. 14 squared. And 15 squared. All right. So that is our list of perfect squares. Okay, we probably won't have to go past that. Okay. Now, these are the numbers that you can take the square root of. These are numbers that you can always take the square root of. So if we look at number 1, what is the square root of 81? 9. Now, what is the square root of 484? Okay, to take the square root on either type of calculator, you do second x squared. Okay, so what is the square root of 484? 22. Okay, for number 3, what is the square root of 64? Okay, now, for questions 4, 5, and 6, they all have a number that's being multiplied to the front of our square root. Okay, so it has 18 times the square root of 4. So it's 18 times, what is the square root of 4? What is 18 times 2? Okay, for number 5, we have 3 times the square root of 256. What is the square root of 256? Yep, and what is 3 times 16? Okay, for number 6, we have negative 5 times the square root of 121. What is that? Or what is the square root of 121? So negative 5 times 11 is negative 55. Okay, now 7, 8, and 9 are all fractional. Okay, when you take the square root of a fraction, okay, it is the same as taking the square root of the numerator and dividing it by the square root of the denominator. So what's the square root of 1? What's the square root of 16? Okay, for number 8, what's the square root of 9? Square root of 100? What's the square root of 25? What's the square root of 49? All right. So those are all perfect square roots. Okay? Sometimes we have things that are not perfect square roots. So when we have to simplify something that's not a perfect square root, okay, I want us to do something real quick. Someone with one of the yellow TI-84s, type in the square root of 24. What did you get?
4.898979.
Okay, now someone with one of these, type in the square root of 24 and tell me what you get.
2 to the square root of 6.
2 to the square root of 6. Okay, so 24 is not a perfect square. Okay, but we can simplify it using perfect squares. okay? When we simplify a non-perfect square, we are writing it, okay, with a square root in it, like this calculator gives us, okay? We cannot rely on these calculators, okay? For this test, you cannot use one of these, okay? You have to use one of those, the yellow TIE4s, okay? Because I want us to be able to do this. Because you will have to be able to do it in the future, okay? Both for my class and for Algebra 2. For instance, there was a whole quiz that they had in Algebra 2 recently that a bunch of people did not pass because they couldn't do this, okay? So I am making sure we can do this. So we cannot use these on our test, okay? Because they give us this. And now, they will not give you simplifying cubes. So you have to know what you're doing regardless. But we're not using these, period, okay? For it, you can practice and check with this. That's fine. But you need to know what you're doing, okay? So what we're going to do, okay, is you have to figure out the biggest perfect square that can go into the base. And when I say go into, I mean what is the biggest perfect square 24 is divisible by, okay? So our perfect squares are right here. So let's go ahead and we're going to start with 24, okay? So we already know that 24 is not divisible by anything bigger than 25, correct? Is 24 divisible by 16? Is 24 divisible by 9? Is 24 divisible by 4? Yes. That is the biggest perfect square that can go into 24. Okay? Now, 4 times what is 24? 6. So we have the square root of 4 times the square root of 6. All we're doing is rewriting this as two things that multiply to give us 24. Okay? And what is the square root of 4? And can I take the square root of 6?
No.
So I just bring down the square root of 6. And so we simplified that square root to 2 root 6. Okay? For number 11, okay, we have 48. Okay? What is the biggest perfect square that can go into 48? Okay, because we know it can't be any of these, right? And it's not 36, and it's not 25, so it is 16. Check them if you need to, okay? Whatever you need to do. 16 times what gives you 48? 3. Okay, so the square root of 16 times the square root of 3. What is the square root of 16?
4.
So it is 4 root 3. All right, now, for number 12, we have the square root of 72, okay? We know none of those can go into it. Can 64 go into 72?
No.
Can 49 go into 72?
No.
Can 36 go into 72?
No.
How many times?
2.
So we can rewrite that as the square root of 36 times the square root of 2, because 36 times 2 is 72. What is the square root of 36?
6.
And can I do anything with the 2? So we just bring it down. 6 times the square root of 2. Yes. When Jaylee gets back. All right. So on the back, we're going to do some more of these. Okay. So if you need to, at the top of your page, if you need to write out your perfect squares again, write them. Okay, if you need to write these right in here, put them there. Okay, I want you to make sure you have them. Typically, you won't be needed to use anything above 15, probably above 10, but okay. So, we're going to look at 2 of these together. And then we're going to I'm going to let you do the other ones. So we're going to do, actually I lied, we're just going to do 18 together. Okay, So for 18, it is the square root of 343. Okay. What is the biggest one of these numbers that can go into 343? 144 can't go in there. 169 can't. 196, 225 can't. Can it? Well, tell me, is it divisible by it?
No.
Is it divisible by 100?
No.
Is it divisible by 89? 81. Is it divisible by 81? 64? It is 49. Okay. How many times can 49 go into it? 7 times. So we have the square root of 49 times the square root of 7. What is the square root of 49? So we have 7 times the square root of 7. Okay. I want you to take a second and I want you to do 13, 14, 15, 16, 17 on your own. So after Jayla goes, Jagger's going, and then you can go.
Yes. Times the square root of 7. And if the thing that you multiply by is
Okay, for 13, what did y'all get for 13?
3 root 7.
3 square root of 7. What did y'all get for 14?
3 square root of 10.
Okay, what did y'all get for 15?
5 square root of 7.
Okay, for 16?
3 root 18.
You could have done it further than that.
Okay.
It is 9 root 2. Okay, so that brings a good point. So what was the numbers you got?
9, the root of 9 and then the root of 18.
Okay, we can take the square root of that, which is 3. But this 18 can break up to 9 and 2. So we could do 3 times 3 times the square root of 2. You have to break it up so you can't break it up anymore. Okay, so that's why it's important to find the biggest perfect square. Because if you can find the biggest one, you won't have to worry about possibly breaking it down a second time.
So, was it,
81 and 2. All right. Let's give you
9?
root 2. All right, for 17, what did y'all get? All right, so for the last bit of class, you have 10 of those to do on Delta Math, okay? And if you did not finish your Delta Math from yesterday, you need to go ahead and do that as well, okay?